Welcome to the Gravity Engine Getting Started video, where we will start with an empty scene and get as far as a spaceship that responds to a single key press, changing its velocity in a gravitational system. So to get started with Gravity Engine, we need to create an object in the scene, which we'll just call Gravity Engine, and add an instance of the Gravity Engine component to the scene, and this will be a singleton, and it will manage all the gravitational interactions of objects in the scene. There are a number of tabs here, pullouts here. In particular, the one that we're taking advantage of is this one that says automatically add n-body, which is the common way to use Gravity Engine. So as we add n-body components to the scene, they will be detected by Gravity Engine, and it will take control over moving them around based on their mass and velocity attributes. So let's go ahead and create a planet. So we'll start with an empty object, change its name to planet, and then in order to keep the scaling of the planet and whatever we want the planet to look like, we'll create a child object, which is a sphere that shows us what the planet is in the scene. And just to make it a little more interesting, we'll go into our images folder here and we'll grab, I don't know, let's take Neptune and put that as our texture on the scene. So we have a Neptune-like atmosphere. And now going back up to the planet, since we want to make it under the control of Gravity Engine, we add an n-body. And here we now see that there's a mass field, so we can indicate the mass. We're going to work in kind of game units, dimensionless units, pick a value of 100, and then it's also possible for us to specify the velocity of this planet, although currently we'll just leave it at the origin and we'll leave the velocity at 0. So let's go ahead and create another object in the scene, which we'll call ship. And again, to make it look a little bit better, we'll pop over into our prefabs folder and we'll grab this station model and make it a child of the ship. It's at position 0, and we'll set it at, say, x is 15 in the scene. Oops, that's the model. We'll go up to the ship and set the ship's position to 15, and then we'll go ahead and add a component, n-body, and we can leave the mass of the ship as 0 because in comparison to a planet, the ship isn't going to exert much force on the planet. It's all about the planet exerting a force on the ship. So we can just leave the ship as mass of 0 for the time being. And that's all we really need to do to have the bare minimum hello world kind of activity in the Gravity Engine asset. If we press play here, our camera's zoomed out a little bit, so the ship comes falling in from the right-hand side and then goes swooshing through because we haven't done any collision detection or anything. So let's just tidy up the camera here. We'll move it a little further back so we can see it in the scene. Skybox doesn't really make a lot of sense for our space applications. Let's go with a sort of lightly tinged background color, and that's all fine. Now, if we want to not have the ship just fall directly into the planet, it needs to have some velocity, and it's going to be useful for this velocity to be in the y direction, so that the ship doesn't hit the planet as it moves and goes in some kind of orbital path. So we can just take a guess and say, let's make y3, and go ahead and have a look at how that plays out. So now our ship takes off in the y direction, but the planet starts to pull it, and it goes off in some fairly wide orbit. So if we try a smaller number like 1.5, and see what results when we do that. Now it's not moving vertically as quickly. The planet has more time to pull it towards itself, and we have a nice, somewhat eccentric elliptic orbit near the planet. Getting exactly the orbit you want could become a matter of trial and error, and it's going to be sensitive to the mass of the planet, the distance you are away from the planet, and the velocity you put in. So if you wanted a circular orbit, calculating the exact velocity for a circular orbit could become a bit of a tedious trial and error exercise, but we don't want that. So we're going to add an element provided by Gravity Engine called orbit ellipse, and what we've done is we've added this to the ship, saying we want the ship to be in an orbit, and we need to say that we want it to be in an orbit around the planet. So we will grab the planet and put it in this slot called center object. And what's happened now is that the orbit ellipse component has taken control of the transform. So as you see up here, the transform now says position orientation are handled by elliptical orbit parameters below. It has by default put us in a circular orbit at units of 10. So we can make the orbit 15 again if we wish to. And if we want to adjust the eccentricity, we can see that change in the scene. If we want to change the axis or the inclination, these are all adjustable. These are all the classical orbit parameters for an elliptical orbit in the scene. And what this does is it essentially is just computing the initial velocity. After that, Gravity Engine is doing n-body simulations of the spaceship, and it will continue in this orbit as long as it's not perturbed by, say, a moon of Neptune if we were to add a moon later, or some other planet further on in the scene. And there it is moving in its path. So it would be useful if we could see what that orbital path was going to be in the scene. Quite handy to see what kind of trajectory you're on. So let's do that next, and what we'll do is we will again add another component to the ship as a child, and we'll call it Orbit Predictor. And we'll go ahead and add a component called Orbit Predictor, as you might guess. And so down here we have our Orbit Predictor element, and it needs two things. It needs to know Orbit Predictor for what body, so that's going to be the ship, and Orbit Predictor around which central object are we orbiting, and that is the planet. You'll notice that the Orbit Predictor requires that a line renderer be present, and so that's been added automatically, and so that's the minimum we need to do. And if we press play, we will see that we do in fact see this hideous pink orbit, but obviously we might want to make that look just a little bit better. So what we will do is we will pick a material out of materials folder here. So let's say let's try green, drop it on the Orbit Predictor, and then we can, with the line renderer, maybe try 0.3, and with number of points, let's maybe add 200 points, and then we can make our orbit look a little bit nicer. So now we have a nicely indicated orbit and a spaceship that's moving around. And again, this orbit is being re-predicted every frame based on the velocity of the ship. So if we change the velocity of the ship, we will see a change in the orbit that's predicted. So now we get to the interesting part. How do we go about changing the velocity of the ship? Well, that's going to require some kind of user input, so we'll just do the simplest possible example of that. So there's a script that's been created called the Getting Started Spaceship script. So we'll call that here. And this script is also listed in the web page that's linked in the YouTube video below. And essentially what this script does is checks for a key binding. In this case, it's the key binding W. And in fact, why don't we go find this Getting Started script? It's in Demo Scripts, Getting Started Ship. So you can see it over here on the side. This is the key line here. Gravity Engine instance apply impulse. And so it's simply going to take the up direction, vector3.up, multiply it by thrust, and apply that as an impulse to the ship's velocity. So it's only going to apply velocity in one direction, and we can see how the orbit is affected by that. So we can go ahead and play the scene. So we're in an orbit. If we press the W key, it changes our orbit. If we get to a different point in the orbit, press the W key, it changes again. And that is the simplest example I can create of how to change the velocity of a spaceship with user input. And it's through using this apply impulse function. There are a number of demonstration scenes that provide draggable handles to adjust the velocity in all three axes, and also some additional demos that go under the Lambert demo series that show you how to actually compute orbit transfers from one orbit to another, as opposed to just grabbing and trying to change the shape of your ellipse to magically match some other orbit. Those are all discussed in some of the other tutorial videos in this series. Thanks for your attention, and I hope this has helped.